All right, here we go again. Moron Electrical, 1910.305. Wiring methods, components, and equipment for general use. My dogs always bark at this standard. Yeah, they're really happy about this one. Anyhow, let's get this ball rolling. This is a pretty long standard here. All right, ball, roll. All right, wiring methods. This provision, the provisions of this section do not apply to conductors that are an integral part of factory assembled equipment. Okay, so it makes a lot of sense, you know. So you got something that's built in a factory and you can't really impose these restrictions on that. General requirements: metal raceways, cable trays, cable armor, cable sheath enclosures, frames, fittings, and other metal non-current carrying parts that are to serve as grounding conductors, with or without the use of supplementary equipment. Grounding conductors shall be effectively bonded where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed on them. Any non-conductive paint, enamel, or similar coating shall be removed at threads, contact points, and contact surfaces, or be connected by means of fittings designed so as to make such removal unnecessary. So what they're saying, bonded, and if it's bonded, it's really going to have a good contact. Where necessary for the reduction of electrical noise, electromagnetic interference of the grounding circuit, the equipment enclosure supplied by a branch circuit may be isolated. I'm not going to read every one of these things because they're applicable only to really a minute portion of it, or specific things that aren't in general industry. No wiring systems of any type may be installed in ducts used to transport dust, loose stock, or flammable vapors. No wiring system of any type may be installed in any duct used for vapor removal or for ventilation of commercial type cooking equipment, or in any shaft containing only such ducts. And that makes a lot of sense. You really want to put an electrical conduit in a duct work, let's get the flammable vapors in there. Temporary wiring, except as specifically modified in this paragraph, all other requirements of this subpart for permanent wiring shall also apply to temporary wiring installations. Temporary electrical power and lighting installations of 600 volts nominal or less may be used only as follows. Okay, this is 600 volts or less temporary wiring we're talking about. During and for remodeling, maintenance, or repair of building structures or equipment and similar activities. That makes sense. So in other words, you can't have permanent wiring if you're just doing remodeling. For a period not to exceed 90 days for Christmas decorative lighting, carnivals, and similar purposes. Now, it's interesting that they put something like that in here because they know it's going to happen. You might as well live with it. You're going to go out writing people up motion for Christmas decorations. That wouldn't make a lot of sense. So they're going to give you 90 days for Christmas lighting. So, okay, or carnivals and that type of thing. Carnivals and also like church carnivals, money fundraisers, for experimental or development work and during emergencies. All right, all that makes sense, doesn't it? Sometimes those should make a lot of sense. Temporary wiring shall be removed immediately upon completion of the project or purpose for which the wiring was installed. And that makes great sense. Temporary electrical installations of more than 600 volts may be used only during periods of tests, experiments, emergencies, or construction-like activities. So that's in temporary installations of 600 volts or more than 600 volts. Now this is still A2, so this is AAA, A2V. Okay, the following requirements apply to feeders. Feeders shall originate in an approved distribution center, and I'm not going to talk about feeders because we're not going to get into that. Branch circuits, same way. Branch circuits shall originate in approved power. Okay, no branch circuit conductor may be laid on the floor. Makes sense. Each branch circuit that supplies receptacles or fixed equipment shall contain a separate equipment grounding conductor if run as open conductors. Receptacles shall be of the grounding type unless installed in a continuous grounded metallic raceway or metallic covered cable. Each branch circuit shall contain a separate equipment grounding conductor, and all receptacles shall be electrically connected to the grounding conductor. No bare conductors nor earth returns may be used for the wiring of any temporary circuit. Now here they say earth returns, which is basically grounding. Suitable disconnecting switches or plug connectors shall be installed to permit the disconnection of all ungrounded conductors of each temporary circuit. Multi-wire branch circuits shall be provided with the means to disconnect simultaneously all ungrounded conductors at the power outlet or panel board where the branch circuit originated. Note, circuit breakers with their handles connected by approved handle ties are considered a single disconnecting means for the purpose of this requirement. We've all seen that. You've seen a panel board that has like three circuit breakers all tied together. So they're considering that as one. And that makes a lot of sense too. That's why they're tied together. All lamps for general illumination shall be protected from accidental contact or breakage by a suitable fixture or lamp holder with a guard. Brass shell, paper lined sockets, or other metal case sockets may not be used unless the shell is grounded. Flexible cords and cables shall be protected from accidental damage, as might be caused, for example, by sharp corners, projections, and doorways or other pinch points. That's something when you're walking through a place you want to look out for. Flexible cords, people will run them anywhere. Extension cords, basically. Cable assemblies and flexible cords and cables shall be supported in place at intervals that ensure that they will be protected from physical damage. Support shall be in the form of staples, cable ties, straps, or similar type fittings installed so as not to cause damage. Cable trays. Only the following wiring methods may be installed in cable tray systems: armory cable, electrical metallic tubing, electrical non-metallic tubing, fire alarm cables, flexible metal conduit, flexible metallic tubing, instrumentation tray cable, intermediate metal conduit, liquid tight flexible metal conduit, liquid tight flexible non-metallic conduit, metal clad cable, mineral insulated, metal sheath cable, multi-conductor service entrance cable, multi-conductor underground feeder and branch circuit cable, multi-purpose and communications cables, non-metallic sheath cable, power and control tray cable, power limited tray cable, optical fiber cables, and other factory assembled multi-conductor control signal or power cables that are specifically approved for installation in cable trays, rigid metal conduit, and rigid non-metallic conduit. That's what is allowed. That's a lot. I don't know what else would not be allowed to. In industrial establishments where conditions of maintenance and supervision assure that only qualified persons will service the installed cable tray system, the following cables may also be installed in ladder, ventilator trough, or ventilator channel cable trays. And I'm not going to read all those, but that would be like in a separate room somewhere. And OK Foods had a lot of those, where they were locked, and if you didn't have a key, you had to have a key to get in, so they weren't open to anybody to get in there. Welding cables installed in dedicated cable trays. These are welding cables. Single conductors used as equipment grounding conductors. Oh, wait a minute. That is. Oh, that's the following methods of can be in cable trays. Okay, single conductors used as equipment grounding conductors. Multi-conductor cable type M. Metallic cable trays may be used as equipment grounding conductors only where continuous maintenance and supervision ensures that qualified persons will service the installed cable tray systems. Cable trays in hazardous classified locations may contain only the cable types permitted in such locations, 1910-307. And cable tray systems may not be used in hoistways or were subjected to severe physical damage. Open wiring on insulators. Open wiring on insulators is only permitted on systems of 600 volts nominal or less for industrial or agricultural establishments, indoors or outdoors, in wet or dry locations, or subject to corrosive vapors, and for services. Conductors smaller than number 8 shall be rigidly supported on non-combustible, non-absorbent insulating materials and may not contact any other objects. Support shall be installed as follows. And I'm that's not going to get into that too much. In dry locations where not exposed to severe physical damage, conductors may be separately enclosed in flexible non-metallic tubing. And there's the length and straps that support it, 4.5 feet. Open conductors separated from contact with walls, floors, wood cross members, or partitions to which they pass. So open conductors is something that's not really good to get into. Where open conductors cross ceiling joints and studs. All right, cabinets, boxes, and fittings. Conductors entering boxes, cabinets, or fittings. Conductors entering cutout boxes, cabinets, or fittings shall be protected from abrasion, and openings through which conductors enter shall be effectively closed. Unused openings in cabinets, boxes, and fittings shall be effectively closed. Talked about that before. You got a junction, a box, a panel like that has openings in it, and things have changed or error erroneously or whatever. They knock out plugs and not put back in. That'll get you. The OSHA inspector will get you for that. And if there's more than one of them, he's going to look harder, because that's kind of what OSHA inspectors do. It makes sense. And if they don't find anything, they're going to say, well, pretty good. If they're going to find stuff, I better look deeper. I'm finding this type of stuff. I don't know what I'll find if I look deeper. And that's just human nature. Where cable is used, each cable shall be secured to the cabinet, cutout box, or meter socket enclosure. However, where cable with an entirely non-metallic sheath enters the top of a surface-mounted enclosure through one or more non-flexible raceways, not less than 18 inches or more than 10 feet in length, the cable need not be secured to the cabinet box or enclosure, providing all the following conditions are met. And this is a more of an installation thing, and I'm not going to get into too much into electric installations. Covers and canopies. All pull boxes, junction boxes, and fittings shall be provided with covers identified for the purpose. If metal covers are used, they shall be grounded. In completed installations, each outlet box shall have a cover, faceplate, or fixture canopy. Covers of outlet boxes having holes through which flexible cord pendants pass shall be provided with bushings designed for the purpose, or shall have smooth, well-rounded surfaces on which the cords may bear. So you're having flexible cords with flexible cord pendants passing through it. They have to be, the holes can't be something that might cut through it. Makes sense. Fixture canopy or pan is used. Any combustible wall or ceiling finish exposed between the edge of the canopy or pan and the outlet box shall be covered with non-combustible material. Combustible wall or ceiling finish. That's something that's frequently overlooked in construction. They think their building is not going to burn. It's the building itself is made of non-combustible materials, but then inside it, they put finishes and furniture and everything else that is combustible, and they wonder why it burnt down anyhow. So, and full and junction box for systems over 600 volts. I'm not going to cover too much, I think over 600 volts, because that's something that on a day-to-day basis, unless you're an electrician, you're probably not going to get into. So that's for 600 volts. Single throw knife switches. Single throw knife switches shall be so placed that gravity will not tend to close them. And knife switches is a switch like this and like that. And that's pretty much the knife switch. Single throw knife switch is approved for use in the inverted position, to be upside down, shall be provided with a locking device that will ensure the blade remains in the open position when so set. Okay. Double throw knife switches, that means they can go either way. Maybe mounted so that the throw will be either vertical or horizontal. However, if the throw is vertical, a locking device shall be provided to ensure that the blades remain in the open position when so set. Single throw knife switches and switches with butt contact shall be connected so that the blades are de-energized when the switch is in the open position. You have to remember when you're looking at these standards that they were written 50 years ago. I don't think you're going to see too many single throw, double throw knife switches. You're probably just going to have a switch that's the same thing, but it's enclosed and just a switch. So back in the day, so that's they had those. I mean, single throw knife switches, I'm not going to be too concerned about that. Switches with butt contact on circuit breakers used as switches shall be connected so that the terminal supplying the load are de-energized when the switch is in the open position. That makes sense. However, blades and terminals supplying the load of a switch may be energized when the switch is in the open position, where the switch is connected to circuits or equipment inherently capable of providing a backfeed source of power. For such installations, a permanent sign shall be installed on the switch enclosure or immediately adjacent to open switches that read, warning, load side terminals may be energized by backfeed. Faceplates for flush-mounted snap switches. Snap switches mounted in boxes shall have faceplates installed so as to completely cover the opening and seat against the finished surface. Grounding. Snap switches, including dimmer switches, shall be effectively grounded and shall provide a means to ground metal faceplates, whether or not a metal faceplate is installed. However, if no grounding means exist within the snap switch enclosure, or where the wiring method does not include or provide an equipment ground, a snap switch without a grounding connection is permitted for replacement purposes only. Such snap switches shall be provided with a faceplate of non-conducting, non-combustible material if they are located within the reach of conducting floors and other conducting surfaces. Switchboards and panel boards. Again, this is more like panel boards shall be mounted in cabinets, cutout boxes, or enclosures designed for the purpose and shall be a dead front. Dead front means there's nothing you can touch on there that's going to hurt you. However, panel boards other than the dead front, externally operatable types are permitted or accessible only to qualified persons. That's where they get you on the, and you have a circuit, a panel board or a electrical circuit, electrical board that has some circuit breakers in it, and one of them is missing, and there's a hole there. That's not a dead circuit. That's not a dead front then, because you can stick your finger in there, and the only dead will be you. And there's your good knife switches again. Enclosures for damp or wet locations. Why we even have them, I don't know. You would switches, circuit breakers, and switchboards. In the wet locations shall be weatherproof enclosures. Conductors for general wiring, insulation. All conductors used for general wiring shall be insulated unless otherwise permitted in this subpart. The conductor insulation shall be of a type that is approved for the voltage, operating temperature, and location of use, which makes sense. Distinguishable. Insulated conductors shall be distinguishable by appropriate color or other suitable means as being grounded conductors, ungrounded conductors, or equipment grounded conductors. Flexible cords and cables. Use of flexible cords and cables. Flexible cords and cables shall be approved for conditions of use and location. And if you wonder why that blue stuff, lines like that are in there, when they copy this over from the OSHA website, that's what happens to those sometimes. And I don't know if there's anything I can do about it or not, other than just go ahead and delete them and type them in. But I figured, what the heck, doesn't hurt. Flexible cords and cables may be used only for pendants, wiring of fixtures, connection of portable lamps or appliances, portable and mobile signs. Elevator cables, makes sense. Wiring of cranes and hoists, makes sense. Connection of stationary equipment to facilitate their frequent interchange. Prevention of the transmission of noise or vibration. Appliances where the fastening means and mechanical connections are designed to permit removal for maintenance and repair. Data processing cables approved as part of the data processing system. Connection of moving parts and temporary wiring as permitted in paragraph A2 of this section. They're talking about basically extension cords, flexible cables. If used as permitted in paragraphs G, C, and I, the flexible cord shall be equipped with an attachment plug and shall be energized from an approved receptacle outlet. Unless specifically permitted otherwise in paragraph G1II, the section flexible cords and cables may not be used as a substitute for the fixed wiring of a structure. That's something you're going to look for, you're going to find. Flexible cords cannot be used for fixed wiring. Now you see a piece of equipment that's got a flexible cord running onto it, and instead of running a conduit to it, that's a no-no. You got to have fixed. If it's a fixed piece of equipment, it should be hardwired in. We run through holes in wall ceilings or floors. You can't run a flexible cord or extension cord through holes in walls, ceilings, or floors. Makes a lot of sense because it's a rife for abrasion or tripping or anything else. Where I run through doorways, windows, or similar openings either. So you got a window opening. That's not, you can't run an extension cord through a window opening either. Which door makes it sense. Guess what? When this doors open and close, they're going to pinch it. We're attached to building surfaces. They're not supposed to be attached to something. Extension cord is supposed to be temporary. We're concealed behind building walls, ceilings, or floors. So if you can't see a part of it, how do you know it's going to get any good, right? Or were installed in raceways except as otherwise permitted in this subpart. And I'm not going to go all this types of show windows for flexible cords. Identifications, splices, and terminations. A conductor of a flexible cord or cable that is used as a grounded conductor or an equipment grounding conductor shall be distinguishable from other conductors. And there's the types of flexible cords. Flexible cords may be used only in continuous lengths without splice or tap. Hard service cord and junior hard service cord number 14 and larger may be repaired if spliced so that the splice retains the insulation, outer sheath properties, and usage characteristics of the cord being spliced. Flexible cords and cables shall be connected to devices and fittings so that strain relief is provided that will prevent pull from being directly transmitted to joints or terminal screws. If you have drops coming down from the ceiling, you look up there and you'll see that the cord comes down, and then there's a hanger coming down, and the cord goes through it before it drops down, and that's your strain release. So there's strain on that cord, including just the weight of the cord, and that's usually a little bit of flexible to that. It won't be pulling the cord where it goes in the junction box. Portable cables over 600 volts nominal. Again, over 600 volts, something you're probably, if you're getting into something that's over 600 volts, you're probably an electrician and you probably want to read this. But this is a class for electricians, so we're not going to go over the over 600 volts, and that's H6. H7, splices. Portable cables may not operate with splices unless the splices of the permanent molded, vulcanized, or other approved types. I can't tell you how many extension cords I have found that I've thrown out, taken out of service. We did a big, huge butter company in Oklahoma City. We did a huge renovation down there, and I walked down there and into it, and there's all kind of stuff going on, contractors all over the place. The first thing I look at is there's an extension cable, 100-foot extension cable on the ground. Now, that's not by itself a problem, and it's a construction thing, and I know it's not going to be perfect, and but I look at it, and there's a break, and there's an open in the insulation. I look at it again, there's another one, so I pulled the plug, and I'm walking through the plant, right, roll this card up, here comes the guy. What are you doing? Like, I'm come back. He's like, this extension cord is no good. It's got breaks in the insulation. Well, what's the only one we got? What are we supposed to do? I said, down to Walmart, get another one. They got all kind of been out of shape. Now, can you cut a cord and splice it? No, not splice it. But if you've got a 100-foot cord and you've got a piece of insulation messed up in the middle of it, you can cut it, make two 49-foot cords, as long as you put an approved plug on each end of it, and it's capable of doing that. That's okay. Then you have an extension cord that doesn't have any openings in it. I mean, any breaks in the insulation, that's fine. But extension cords are something to be look out for as a safety professional. Fixture wire should be approved for the use, of course. Fixture wires. I'm not even sure what a fixture wire is. Installation of lighting fixtures and similar equipment, and bending and twisting for connecting light fixtures to the branch circuit. Not permitted, may not be used as a branch circuit conductors, and I'm not going to get printed for class 1 power circuits and for fire alarm circuits. Okay. Equipment for general use: lighting fixtures, lamp holders, lamps, and receptacles. Fixtures, lamp holders, lamps, rosettes, and receptacles may have no live parts normally exposed to employee contact. However, I like that. No live parts. However, rosettes and cleat type lamp holders and receptacles located at least 8 feet above the floor may have exposed terminals. Okay. My rule on that one. If it's within 7 feet of the floor work surface, you can touch it and it can hurt you. It must be guarded. And that's whatever, electrical, mechanical, anything. That's a good rule to follow. So 8 feet, okay. Now, I might take a little bit of exception to something that's electrical and open, because at 8 feet above it, you could still hit it with something you're carrying. So you have to kind of be careful about that. Hand lamps of the portable type supplied through flexible cords shall be equipped with a handle of molded composition or other material defined for the purpose, and a substantial guard shall be attached to the lamp holder or the handle. Metal shell paper-lined lamp holders may not be used. I don't even think these are around anymore, but they might be. Lamp holders of the screw shell type shall be installed for the use as lamp holders only, or supplied by a circuit having a grounding conductor. The grounding conductor shall be connected to the screw shell. Lamp holders installed in weather damp locations shall be of the weatherproof type. Fixtures installed in weather damp locations shall be identified for the purpose and shall be so constructed or installed that water cannot enter or accumulate in wireways, lamp holders, or other electrical parts. Receptacles, cord connectors, and attachment plugs, caps. All 15 and 20 amp attachment plugs and connectors shall be constructed so that there are no exposed current carrying parts except the prongs, blades, or pins. The cover for wire terminations shall be a part that is essential for the operation of an attachment plug or connector, dead for construction. Attachment plugs shall be installed so that their prongs, blades, or pins are not energized unless inserted into an energized receptacle. No receptacles may be installed so as to require an energized attachment plug as its source of supply. Receptacles, cord connectors, and attachment plugs shall be constructed so that no receptacle or cord connector will accept an attachment plug with a different voltage or current rating than that for which the device is intended. However, a 20 amp T-slot receptacle or cord connector may accept a 15 ampere attachment plug of the same voltage rating. Non-grinding type receptacles and connectors may not be used for grinding type attachment plugs. A receptacle installed in a wet or damp location shall be suitable for the location. A receptacle installed outdoors in a location protected from the weather or in other damp locations shall have an enclosure for the receptacle that is weatherproof when the receptacle is covered. Attachment plug cap not inserted and receptacle covers closed. Note, a receptacle is considered to be in a location protected from the weather when it is located under roofed, open porches, canopies, marquees, or the like, and where it will not be subjected to a beating, rain, or water runoff. I laugh about this because we put a plant in West Virginia. And at the time, I wasn't the plant manager, and this guy named Steph was his nickname. And he was he was an older fellow, and they hired him to be the plant manager, and that's fine. We were putting the stuff in it, and I worked closely with the maintenance guy. In fact, he was a buddy of mine, and we knew what we were doing. We wanted, we did something. We knew what we were doing anyhow. And we were going to have, we had overhead busways and plug in the connectors at different spots. And we're going to get a drop cord down to come down to each sewing machine. And these were removable, which was great. And so he was going to do, this is what happens when somebody doesn't know what they're doing, so tries to micromanage. He was going to try to micromanage this stuff, And he was going to have us put the live plug, the male plug coming on the drop down. And which means you'd have voltage right on that plug which you could touch. And once we pointed that out to him, and that was not a good idea, he quickly acquiesced and kind of let us do it ourselves because we knew what we were doing. So I can't believe a guy at his age didn't know that, but he was a nice guy, and but he didn't last too long. Plant manager. All right. A receptacle installed in a wet location where the product intended to be plugged into it is not attended when in use, for example, sprinkler system controllers, landscape lighting, and holiday lights, shall have an enclosure that is weatherproof with the attachment plug cap inserted or removed. A receptacle installed in a wet location where the product intended to be plugged into it will be attended while in use, for example, portable tools, shall have an enclosure that is weatherproof when the attachment plug cap is removed. Appliances may have no live parts normally exposed to contact other than parts functioning as an open resistance heating elements, such as the heating elements of a toaster, which are necessarily exposed. I was always taught to not stick my fingers down in a toaster. And I still obey that to this day. I still don't do it. So each appliance shall have a means to disconnect it from all ungrounded conductors. If an appliance is supplied by more than one source, the disconnecting means shall be grouped and identified. So if you got a whole bunch of toasters, all right, we're gonna go there. But that's good that they put something in there and they give you an example, which is a good example of an appliance that has exposed electrical parts, the heating elements. Each electric appliance shall be provided with a nameplate giving the identifying name and the rating in volts and amperes or in volts and watts. If the appliance to be used in a specific frequency, if the appliance is to be used on a specific frequency or frequencies, it shall be so marked. Where motor overload protection external to the appliance is required, the appliance shall be so marked. Markings shall be located so as to be visible or easily accessible after installation. This paragraph applies to motors, motor circuits, and controllers. If specified in paragraph J4 of this section that one piece of equipment shall be within sight of another piece of equipment, the piece of equipment shall be visible and not more than 50 feet from the other. So within sight of means visible and within 50 feet. And that makes sense. An individual disconnecting means shall be provided for each controller. A disconnecting means shall be located within sight of the controller location. However, a single disconnecting means may be located adjacent to a group of coordinated controllers mounted adjacent to each other on a multi-motor continuous processing machine. The controller disconnecting means for motor branch circuits over 600 volts nominal may be out of sight of the controller if the controller is marked with a warning label giving the location and identification of the disconnecting means that is to be locked in the open position. So there you go. They have a rule, and then the next paragraph, they break it. Oh well. The disconnecting means shall disconnect the motor and the controller from all ungrounded supply conductors and shall be so designed that no pool can be operated independently. The disconnecting means shall plainly indicate whether in the open or off position. The disconnecting means shall be readily accessible. If more than one disconnect is provided for the same equipment, only one need be readily accessible. So that's, your typical pull down. You're on the wall on the box. You pull it down. It's 220 and three phase. It's got three fuses coming down. That's one switch pulls them all down. That's what it's supposed to do. An individual disconnecting means shall be provided for each motor, but a single disconnecting means may be used for a group of motors under any one of the following condition. A single disconnecting means shall be provided for each motor, but a single disconnecting means may be used for a group of motors. And they get it. Okay. If a number of motors drive several parts of a single machine or piece of apparatus, such as a metal or woodworking machine, crane, or hoist, if a group of motors is under the protection of one set of branch circuit protected devices, or if a group of motors is in a single room within sight of the location of the disconnecting means. Motors, motor control apparatus, and motor branch circuit conductors shall be protected against overheating due to motor overloads or failure to start, and against short circuits and ground faults. These provisions do not require overload protection that will stop a motor where a shutdown is likely to introduce additional or increased hazards, as in the case of fire pumps, or where continued operation of a motor is necessary for a safe shutdown of equipment or process, and motor overload sensing devices are connected to a supervised alarm. So in other words, an overload device doesn't have to shut it down if it's connected to a supervised alarm. People know that it's overloading if it's something that has to be run, like, for instance, a fire pump. Where live parts of motors or controllers operating at over 150 volts to ground are guarded against accidental contact only by location, and where adjustment or other attendance may be necessary during the operation of the apparatus, suitable insulating mats or platforms shall be provided so that the attendant cannot readily touch live parts unless standing on the mats or platforms. Transformers. We're not going to transformers or something you're probably not going to mess with unless you're an electrician. So, but dry type transformers, I'm not going to worry about transformers too much. And that's not those toys that change from an airplane to a robot. Okay, that's not what we're talking about here. We're talking about a transformer for electrical installations. All right. Like sign them, okay. Oil insulated transformers installed indoors shall be installed in a vault. Makes sense. Combustible material, combustible buildings and parts of buildings, fire escapes, and door and window openings shall be safeguarded from fires that may originate in oil insulated transformers attached to or adjacent to a building or combustible material. So, but in other words, they're saying anything combustible and fire escapes, doors, and window openings have to be safeguarded in this transformer. Transformers catch on fire sometimes. Transformer vaults shall be constructed so as to contain fire and combustible liquids within the vault and to prevent unauthorized access. Locks and latches shall be arranged that a vault door can be readily opened from the inside. And that makes a lot of sense too. If you're in a vault and it accidentally the door closes while you're in it, you need to get out, be able to get out. And that's, that's with any building, any door, rather. Any pipe or duct system foreign to the electrical installation may not enter or pass through a transformer vault. Oh, now here you go. Piping or other facilities provided for vault fire protection or for transformer cooling are not considered foreign to the electrical installation. Well, that makes sense too. Material may not be stored in transformer vaults. One of the things you'll see common in industry is people just putting stuff where it doesn't belong. And this is one case like that. They'll put it in front of fire extinguishers. They'll put it in front of doors, exit doors. They'll stock stuff in front of electrical panels. That's a big problem. And that's just being, I'll be honest with you, that's just people being lazy. Capacitors, except all capacitors except surge capacitors or capacitors included as a component part of other apparatus, shall be provided with an automatic means of draining the stored charge after the capacitor is disconnected from its source of supply. And here's just more than 600 volts. So again, that's six double I. And that's double I also. And this is over 600 volts. Storage batteries. Provisions shall be made for sufficient diffusion and ventilation of gases from storage batteries to prevent the accumulation of explosive mixtures. I don't want to make storage batteries. They just mean batteries, and batteries are basically storage or storing electricity, right? But if you have a battery operated forklift, you have a charging room, and that's one of the things I would think that would be here apply here. They do produce gases, and you need to get them out of there. And that's it for that section. It's kind of long. Some of it is pretty technical, and but there's some good information in there too. So we're going to keep moving on here on subpart S, and you know what S stands for? Yeah, safe.